Today we are going to start with our first chapter, sets. When we talk about set, we mean a collection of objects. Mathematically, a set is defined as a well-defined collection of objects. For example, if I say collection of vowels of English alphabet. Now in the definition of set, we have said that a set is a well-defined collection of objects. So first we have to understand what is the meaning of a well-defined collection. Now look here. Collection of vowels of English alphabet. A collection is said to be a well-defined collection if, given a collection and an object, we are able to decide clearly whether that object will belong to that collection or not. Now here, collection of vowels of English alphabet. It is a well-defined collection because if I am given a letter, for example, E, now I can decide clearly whether this E will belong to the collection or not. Now as E is a vowel, so E will belong to this collection. So collection of vowels of English alphabet is a well-defined collection, so it is a set. And elements which will belong to this collection will be A, E, I, O, U. Similarly, collection of natural numbers less than 4. It is also a well-defined collection because given a number, I can clearly decide whether that number will belong to this collection or not. For example, if I am given the number 5, I can clearly state that this 5 will not belong to this collection because this number is not less than 4. So it is a well-defined collection, therefore it will represent a set. And the elements or the members which belong to this collection will be 1, 2, 3. Natural numbers less than 4. So thus we have seen that collection of vowels of English alphabet and collection of natural numbers less than 4, they both are example of a set. Now consider another example. Collection of tall students of class 11th of your school. Now it is a collection of tall students of class 11th of your school. Is it a well-defined collection? Answer is no. Because here this parameter tall is not well defined. Because given a student to one person, that particular student is considered as tall. But the same student, according to some other person, may not be tall. So we will not be able to decide whether a particular student will belong to this collection or not, because the opinion will vary from person to person. So collection of all tall students of class 11th is not a set because it is not a well-defined collection. But if I say collection of all students of class 11th whose height is more than 155 centimeter. Now this collection is a well-defined collection because here the parameter height is more than 155 centimeter is a well-defined. Because given a student, I will be able to decide clearly whether that particular student will belong to this collection or not. If the height of that student will be more than 155 centimeter, he will belong to that collection. If the height is less than 155 centimeter or equal to 155 centimeter, that student will not be a part of this collection. So now this collection will represent a set because it is a well-defined collection. A set is denoted by a capital letter, and the objects of a set are called the elements or the members of the set. For example, collection of natural numbers less than 4. We have seen that it is a well-defined collection, so it will represent a set. So a set is always denoted by a capital letter, so I'll denote this collection, say, with the capital letter A. And these elements 1, 2, 3 are called the elements or the members of the set A. Now take another example. Collection of whole numbers less than 5. Now it is a well-defined collection, so it will represent a set. So let us denote this set by the capital letter A. Now the members of this set will be, that means the numbers which will belong to this collection are 0, 1, 2, 3, 4. Whole numbers less than 5. Now look here. 1 is an element or the member of the set A. So I write this as 1. This symbol stands for belongs to, or which we read as an element of. So I read this as 1 belongs to the set A, or I say that 1 is an element of the set A. Similarly, 6 is not a member of this set A. So I will write 6. Now this is the symbol for an element of, but 6 is not an element of set A. So I'll write this way. So I'll read this as 6 is not an element of the set A, or I'll say 6 does not belong to the set A. So this symbol stands for does not belong to, or not an element of. So remember this. This symbol stands for an element of, and this symbol stands for is not an element of. So here 3 is an element of the set A. So I will write 3 belongs to the set A. 5 is not an element of this set. So I will write 5 does not belong to the set A. Now here are some standard set notations. This symbol capital N denotes the set of all natural numbers. That is, capital N stands for the set with the elements 1, 2, 3 and so on. All natural numbers. W denotes the set of all whole numbers. That is, W is equal to the set consisting of elements 0, 1, 2, 3 and so on. Z denotes the set of all integers. That means Z is equal to 0, 1, 2, 3, so on, natural numbers together with the 0 and the negatives of natural numbers. This is the collection of all integers which is denoted by Z. In some books, the set of all integers is denoted by I also. Q denotes the set of all rational numbers. And you know that rational numbers are the numbers which are in the form of P by Q, where P and Q are integers and Q is not equal to 0. So the set of all rational numbers is denoted by the symbol Q. R denotes the set of all real numbers. And you know that real numbers are all the rational numbers and all the irrational numbers put together. So the collection of all rationals and irrational numbers, that is the collection of all real numbers, is denoted by the symbol R. So that means if I say X belongs to N, this means that X is a natural number. If we write Y belongs to W, this means that Y is a whole number. If I write P belongs to Z, it means P is an integer. If I write X belongs to Q, this means that X is a rational number. And if I write W belongs to R, this means that W is a real number. Now we will learn how we represent a set. So, representation of sets. There are two ways in which a set can be represented. One is the roster form and the other is the set builder form. So first we will discuss the roster form. In roster form, a set is represented by listing all the members of the set separated by commas and enclosed within brackets. That means when we represent a set in roster form, we list all the elements of that set without repetition. For example, set of letters of the word grammar. We know that a set is denoted by a capital letter, so I denote this set with the letter A. Now this set will be represented by, yes, the first letter is G, next letter is R, then A, next is M, again we have M, but we will not repeat the letter. Next is A, which has already been listed, and next letter is R, which is already there. So the set of letters of the word grammar has 4 elements, G, R, A, M. So we have listed all the elements, separate them with commas and enclosed the elements in the brackets. So this type of representation is called the roster form of representing the set. Let's take another example. Set of natural numbers less than 6. I denote the set with the letter B. Now, natural numbers which are less than 6 are 1, 2, 3, 4, 5. So these are the members of this set. I have listed all the members. I separate them using commas and enclosed all the members in the curly brackets. So this is the roster form of this set. Next we have the set builder form. In set builder form, a set is represented by stating the common property possessed by the elements of the set. That means when we represent a set using set builder form, we do not list all the elements. Instead, we state the common property which is possessed by the elements of that set. For example, consider the set A with elements 1, 2, 3, 4, 5 and 6. Do these numbers share a common property? Yes, they all are natural numbers. So, I can represent this set as A. This curly bracket means the set consisting of all x followed by colons, and this stands for such that x belongs to n, that is x is a natural number and x is less than 7. Or I can simply write collection of all x such that x is a natural number less than 7. So here you can see that I have not listed all the elements. I have just stated the property possessed by the elements of the set. So here this is the set builder form and here this is the roster form. Let's take another example. Consider the set B with elements 2, 3, 5, 7. What is the common property possessed by the elements of this set? Yes, they all are prime numbers. So I write this set as collection of all y such that y is a prime number less than 8. Less than 8. So this is the set builder form of the set B. Let's take another example. Consider the set C with elements 5, 10, 15, 20. I have to represent this set using set builder form. That means I have to represent this set by stating the common property possessed by the elements of this set. Yes, can you identify the property? Yes, they all are multiples of 5. This is 5 into 1. This is 5 into 2. This is 5 into 3. And this is 5 into 4. So, I'll write this set as collection of all x such that x is equal to 5n, where n is a natural number and n is less than equal to 4. So this is the set builder form of this set. Let's take another example. Set D consisting of elements 1, 4, 9, 16, 25. I have to write this set using set builder form. So first I have to identify the common property. And here in this case, you can see that these are the squares of the natural numbers. This 1 is square of 1. This is square of 2. This is square of 3. This is square of 4. And this is square of 5. So I will write D as collection of all x such that x is equal to n square, where n is a natural number and n is less than equal to 5. Again, suppose I write the set E Firstly, let us see how we read this. Name of the set is E, so I'll read this as set consisting of all x such that x belongs to W, and W means the set of whole numbers, and x is less than equal to 3. That means E is the collection of all whole numbers which are less than equal to 3. So if I have to write this set in roster form, I'll write this as 0, 1, 2, 3. All whole numbers less than equal to 3. So this is the roster form and this is the set builder form.